this is a very difficult multiple choice question on materials. It compares two wires, x and y. It tells you they have the same mass, they have the same extension, but the key difference and the only difference is the diameters are different. The diameter of wire y is 2 times larger than the diameter of wire x. So let's make a note of that. That's the key difference. So this is a diameter d and this is a diameter 2d. What does that mean for the radiuses or with the radii? That means that the radius of wire y is also 2 times larger than the radius of wire x. Now, what effect will that have on these two equations? That's what it's asking, this multiple choice question. Well, first of all, I made a few notes here so you can have a go yourself if you want. But the volume of any wire is the cross-sectional area of the wire because it's a cylindrical shape multiplied by the length of the wire. The reason it's a cylindrical shape is if you cut a wire open, this is what you'll see, a cylinder. Now, doubling the radius, what effect does that have on the area? Well, we know the area of any circle is pi r squared. So if r is doubled, then you're essentially squaring 2r. 2 squared is 4, so this becomes 4r squared, meaning we're going to have 4 pi r squared instead of just pi r squared. So essentially, if the radius is doubled, the area of the wire is quadrupled. If the area of the wire is quadrupled, that means that the volume of the wire is quadrupled. Because we mentioned both wires have the same mass, if you're multiplying by a volume that's 4 times larger, density is inversely proportional to volume in this equation. And so if the volume is 4 times larger, the density would have to be 4 times smaller. So we know it's definitely either option C or D. So let's move on to the Young's modulus part of the experiment. Now, we know that it's stress divided by strain, and because if you want me to explain how this equation is formed, just watch the next 20 seconds, or otherwise you can just skip the next 20 seconds. But stress is force over area. We're dividing by extension over length. Extension can also be labeled as little e or little x, depending on what specification you're in. But when you divide a fraction, you're multiplying by the reciprocal of the second fraction. So it becomes force times length divided by area multiplied by extension. So we mentioned that they have the same mass, so the force experienced is the same. It's due to weight. Weight is mg. If m and g are constant, then the force will also be constant. The length of both wires is the same. The extension of both wires is also the same. It mentions that here. But like we mentioned before, the doubling the radius, it will make it so that the area is 4 times larger. And after area is 4 times larger, again, this is inversely proportional to the Young's modulus, meaning the Young's modulus would be 4 times smaller. So our correct option is C, because it matches both of the criteria that we're looking for. If you enjoyed the video, please like, comment and subscribe with notifications on, and I've linked my email in the description if you have any tutoring inquiries. Otherwise, thanks for watching.